Hi folks, here we are again, and we're going to talk about converting things. So this is a big skill we need in chemistry, and the reason we need it is sometimes we use one measurement, and sometimes we'll use a different measurement system, and we have to be able to change from one to another really easily. It's just like when you go to a foreign country and you take your English dollars and you want to change it into a different foreign currency, you have to know what the conversion factor is, what the going rate is. And so we have to convert our money into a different kind of money, and we have to know how much money we can get in the new country. So we're going to use converting to figure that out, and we do it in science as well. So what happens when a measurement is multiplied by a conversion factor? Just like our money, we can convert from English dollars, American dollars to English pounds or things like that using a conversion factor. So conversion factor is a ratio. It's like how much the US dollar is worth and how much the British pound is worth. That's a conversion factor. Or how much a Canadian, I think they're in dollars, compared to a Mexican peso. There's a converting ratio between those two. That's called a conversion factor, and we're going to use these a lot. So for example, 1 meter is 100 centimeters. That's a conversion factor, and we usually write it as a fraction like this. So 1 meter, 100 centimeters is called a conversion factor, and we can use that to figure out how many centimeters, if we had a certain number of centimeters, how many meters that is. So the smaller numbers up there, larger units up there, larger number down on the bottom, but a smaller unit on the bottom, and they're equivalent to each other. So 1 meter is the same thing as 100 centimeters. So when we use that conversion factor, we're going to multiply. The actual value, the quantity, is not going to change. It's just what unit we use. So remember, we always have to have a number and a unit. So we're changing the units, not the quantity. So this one is a really tiny micrograph of a really small thing. And we can convert from nanometers to meters because there's a lot of nanometers in 1 meter. How we're going to use something called dimensional analysis. So sometimes you'll hear it called unit analysis or dimensional analysis, and we're going to use this a bunch in this class. So it's a way to analyze and solve problems using units or dimensions of measurements. And it gives you another way to approach problem solving. So if you had a job and you worked 8 hours and you are super bored at that job and you want to know how many seconds you have to endure to get through that day, we can figure that out using dimensional analysis and conversion factors. So we're working 8 hours. We know that every hour has 60 minutes in it and every minute has 60 seconds in it, and we can use all those things to figure out seconds. So we'll start with our boring 8-hour job. We know that there's 60 minutes in 1 hour, and there's 60 seconds in 1 minute. If we multiply all this together, we get this. So we have to sit in that boring job or do that boring task for that many seconds, and it seems even worse. So I don't know if we should do this math at all. So this is how we go from hours to minutes. The hours cancel out, and then we're in minutes, and then we have to cancel out the minutes, and then we can. So we're going to use this process in chemistry over and over and over again. So we have to get fast and good at it. So whatever unit is here has to go down here to get rid of it. Whatever unit's here has to go down there to get rid of it. And then you're going to end up with the unit that you want. We wanted to figure out how many seconds we're going to be sitting in this boring job. So that's what we figured out. And the numbers at the top multiply together, and then get divided. You multiply the bottom numbers together, so 1 times 1 is 1, and then you divide your answer by the bottom number. So we divide by 1, so we get the same answer. But numbers up top multiply, and are divided by, you multiply the bottom numbers, take the top answer, divide by the bottom answer, and you get the final answer. That's how we do dimensional analysis. So let's try another problem. Say you have 50 grams. Say I'm going to have you guys do a lab with copper wire, and I have 50 grams of it, and I know each student needs 1.84 grams of copper to do the experiment. How many students can I get, am I able to have do this lab? So what do we do with those two numbers? We have to figure out a way to use that. So we know that we have 50 grams total. I have 50 grams total, and each student needs that many. So that many grams for every one student. And we have to figure out how many little segments of copper wire do I have, and so how many students can do the lab. So I'm going to start with the big amount of wire. I'm going to divide by, so grams are here, so I know that grams have to go down there. And then I know that if I have 50 grams and each student needs 1.84 grams, I'm going to have 27 students who could do the lab. And we can't have parts of the students, so we're going to say 7 students could do this lab, and we'll have a little tiny bit extra. So that's how we do dimensional analysis, and we'll use this a lot in this class. So what kind of problems can we do with this process that I just showed you? So when we have one measurement in one unit and we need to convert to something equivalent in a different kind of unit, then we're going to use this dimensional analysis. And so could we take 750 decigrams and change it to grams? Sure, because they're both grams, and we know that we can change from one to the other. And we can use this equivalency right here. So whenever you see something equal to each other, we can write it as a fraction. So what do you think we're going to start with in this problem? Are we going to use this thing, or are we going to use that thing to start with? So usually it's the number given to you in the problem. The number and the units given to you in the problem, you start with that. So I'm going to start with the decigrams, 750, and then I know and then decigrams are here, so I got to put it down below on the next step. So it has to go down here. Oops, sorry. Has to go in there on that step, and then I know that for every 10 decigrams I have 1 gram, so decigrams cancel out, and I'm left with grams. So 750 divided by 10 is 75, and that's my answer. I changed to grams, which is what I wanted me to do. So sometimes you can have more than one step, like we showed you on when we were talking about working 8 hours at a boring job. How many seconds is that? Same thing, we can do lots and lots of steps to get from one place to another using these conversion factors. So let's say we have to do that many centimeters to micrometers. So I'm starting with this length, and I want to get to these guys, micrometers. So I know centimeters, there's 100 centimeters in 1 meter. And then I also know there's that many micrometers in 1 meter. So I have to do 2 steps in this problem to get to where I want to get to. Start with centimeters, put centimeters down there, get to meters, get rid of meters by putting it down there, and then getting to the micrometers. Then the math, you take this in your calculator, times that in your calculator, divide it by that in your calculator, and you'll get that answer. So try that out so you can do that, especially in the EE key. So see if you can figure that out. So we have sometimes we have complex units that are a ratio of 2 other units. So these are more complicated. So this thing right here is called the density. So it's a mixture of grams and cubic centimeters. And so that's called more of a complex kind of unit, but we're going to use this a lot. It's called density. So we know the density, and we're trying to figure out, instead of grams per cubic centimeter, what would it be in kilograms per cubic meter? So we're going to have to do a bunch of steps on this one. So this is what we started. We know this is the density. We have to go from grams, and we're trying to change to kilograms. So there's 1,000 grams in 1 kilogram. And then we're trying to change from cubic centimeters into cubic meters. So that's the conversion factor for that. So those two cancel out, and then I'm at where I want to be, cubic meters. So I'm going to have kilograms per cubic meters when I'm done. So number-wise, math-wise, in the calculator, take that times that, divide by that, you get that answer. So try that in your calculator. Good luck. And we need to know how to do these. So let's see if you can do our little quiz. Okay, so I'm going from 1 megagram to kilograms. And this might be a little bit hard to see, so let me show you what the answer is for this one. So this is the conversion factor between those two things. Remember, if you see equal sign, you can always change this whole thing into a fraction, which they did right there. Okay, so it's a conversion factor. Let's try the next one. The conversion factor used to convert joules to calories changes what? Okay, let's see what you guys think. So it changes the value, numerical value of the measurement, but it's really there, not the quantity of energy. So not the amount of energy, it's just the unit that you're using. Okay, one more question. How many micrograms are this many grams? This needs paper and pencil, I think. So this might be a little bit hard of just trying to look at this, but if you want to pause the video and then change from grams to micrograms and see if you get the right answer, that'd be fabulous. So I'll give you a sec. And you can pause, and here's the answer. So see if you can go from grams to micrograms from what we did in notes earlier. Okay, this is really important stuff, so please focus on this and try really hard on this section. Okay, talk to you soon. Bye.